Welcome to this presentation from VMware Explorer, frustration-free Kubernetes for Spring developers. So before we get started, I'd like to just show you this disclaimer slide. Please read through it, take notice of the information, give you a little bit of time to take a look at it. All right, so let's get started. First, just like to introduce myself. My name is Ryan Baxter. I'm an engineer on the Spring team. I've been working on the Spring team for about 8 years now. The entire time I've been on Spring team, I've actually been part of the Spring Cloud team, working on all kinds of different Spring Cloud projects, from Spring Cloud Config to Spring Cloud Netflix. But lately I've been focusing on Spring Cloud Kubernetes, and hence why I want to give this presentation. So here's my contact information. Feel free to get in contact with me whenever you'd like. I'm happy to always interact with people whenever they have questions or need help. So our mission today, if you choose to accept it, is to get a Spring Boot application running on Kubernetes. And we particularly want to take a look at this from the perspective of a developer. From a developer perspective, you have a pretty good process for building out applications, right? You go to your IDE, you write some code, you run the application, test it out, see if the code works, write a little bit more code, test it out, maybe write some tests. And the feedback loop from writing tests to seeing if it works is very quick. And so you can iterate quite fast. And that's great when you're getting started. But most of the time, the applications are not going to be running on your local machine. They're going to be running on some type of platform. In this case, we're going to be talking specifically about Kubernetes. So what happens when it comes time that you actually want to try the application out on Kubernetes? And maybe you need to do a little bit of development while the application is running on Kubernetes. And on the surface, it sounds pretty simple to do. But when you start to dig down into this, you end up having to gain a lot of knowledge, write a lot of configuration, and just manage a lot of moving pieces that really have nothing to do with you as a developer building applications, but takes away from your main focus as a developer. So we want to make this as painless as possible. And so the best way to illustrate this is to really use an example, an application, right? So we're going to not use the most basic Hello World application, Spring Boot application, but instead we're going to add a few more pieces to our application that makes it somewhat more kind of an intermediate level application, just to really illustrate how well you can actually do this and how easy it can actually be, even with all these different moving pieces. So our application is nothing too crazy, but it's also not the simplest thing. And so basically, it's going to have a single endpoint on it, and it's basically going to ask a random person if they'd like to go see a random movie. And the list of random movies that we get to pick from is stored in a database, in this case, a MySQL database. And the name that we're going to randomly ask to go see a movie with is going to come from this third-party application called the name service, right? This is maybe some other team in your organization has built this application. They're responsible for it. It's a black box to you. You just know the API that you need to hit in order to get the random name back. We're going to externalize our configuration like all good cloud-native applications should to a Spring Cloud config server backed by a Git repo. And we're also going to use Spring Cloud Discovery Server, for example, to figure out where the name service is located. And we'll also use Spring Cloud Load Balancer to load balance amongst various instances of the name service that might be available. This is a pretty typical Spring and Spring Cloud type of application. And so if we were to want to build our app and develop our app locally, we also need to get these services running. And so one way that you can go about doing that is using something like test containers. So in Spring Boot 3.1, we introduced support for running test containers in development. And so we can take a container for each one of the services that we need, spin them up as test containers, and run and develop our application in that fashion. So we might have a test container for MySQL, a test container for the name service, which is provided to us by the name service team. And maybe in our infrastructure team has provided containers for things like the discovery server and the config server as well. So everything we need can be spun up locally in containers. Let's go ahead and take a look at how that might work locally and take a look at how this application is going to actually be built out. So we're going to go over to our IE here, and we're going to create a new project here. And so we use the built-in start.spring.io integration IntelliJ here. We'll call it frustration-free gates. And we're going to use Java. We're going to use Maven. We'll use Java 21 as our JEK. And we'll obviously package as a jar. And we'll select our list of dependencies here. As developers, DevTools is going to be particularly useful for us. We already mentioned that we're going to use test containers, so we're going to add that as well. We're going to have a REST endpoint, so we'll use Spring Boot Web. We're also going to go ahead and we're going to use MySQL, so we need Spring JDBC as well. And we'll actually add the MySQL driver in the mix here. Actuator would also be somewhat useful for us. So we'll add that. A couple of Spring Cloud dependencies. So Spring Cloud Load Balancer. We need Eureka Discovery Client. We need the config client, right, as well. So here we'll add the config client. That's all our dependencies. So we'll click Create. And so let's go ahead and start building out the code for our app here. And we will go ahead and start by creating a record that represents a movie. And it's going to have an integer ID and a string name. CRUD repository to access the movies that are in our database. So we'll create interface movie repository, which extends list CRUD repository. And we're going to add our own method in here. And this method is actually going to return a random movie from the database. So we'll say default random movie. And we're going to get a list of movies, find all. And then we will return movies.get new random next in movie size. And this needs to return a movie. That. And then we're going to create a configuration class at configuration class myconfig. And in here, we're going to create a load balance bean for REST template. We're actually going to use new REST template builder.build as we should. So this is going to use Spring Cloud Load Balancer and Spring Cloud Discovery Client under the covers to load balance and look up services by their service name when we make requests using this REST template. And then finally, we're going to use this REST template in our REST controller. And we're going to create a class called movie controller. And movie controller is going to do this. Looks right. This we don't really need. Here we're going to say, we're going to get a random movie. Then we're going to say hello. And then we're going to make a call to the name service here. This is the service name for the name service. And so Spring Cloud Discovery Client, Spring Cloud Load Balancer, and our REST template here is going to take care of resolving that properly for us. And we're going to ask them, would you like to go see a movie? And so we have our app up and running here. So next thing we want to do is configure our test containers. So Spring Boot is Start.Spring.io has already provided us with our test application and our test container configuration. So we're going to go in our test container configuration here. And we're going to replace the default, which tries to help out by giving us a MySQL container, but we have some more stuff that we actually want to do. So we have test container config here, and I'll explain a little bit about what's happening here. Just import this class. Oops. And so we have our MySQL container, which we had before. We have the name service container. And so this is running a container provided to us by the name service team, which is great. And then we have this test container discovery client. So since we're using test containers and test containers are exposing the local host or exposing these containers on a random port locally, we can actually build our own discovery client. We don't need to use Eureka because actually the container has no idea what random port locally is being started on the test container. So it's actually advantageous to us to do it for us. So we're actually configuring our own discovery client here, which is configuring our Kate's Workshop name service and knows what the host and port of that is. Okay. Just to explain that piece. And then the last thing we're missing here is our config server, right? So actually we need to start the config server container as part of the application class here. And I'll explain why in a second. The reason why we do this is because we need to set Spring config import. And we need to set Spring config imports very early on before the application starts, or else it won't be picked up because these are resolved extremely early on when the Spring Boot app starts. So we need to start the container here so that we can figure out what the host and port are, and then we can pass that host and port on along to in our configuration. And we disable Eureka because we're providing our own discovery client in this case. The other thing here is we're mounting a file within the container, and this file is actually this instance of the config server is actually serving up configuration locally. So we're going to mount this file in here, and it's going to serve as the application YAML for our config server. So what we need to do is actually go in here and say new directory, resources, and a new file, and test config YAML, and test config YAML. Here is really just initializing Spring SQL, and we'll come and do that in a second to initialize the database with some data in it, and then we're exposing some actuator endpoints. So we need to make sure that we initialize our container, our application with some data. So we're going to go in here and we're going to create a new file, and we'll call it schema.sql and schema.sql. And this is going to create a table with an ID and then a name for our movies. And then we're going to populate that table with some data. So we'll create a data.sql class here as well. And we're just going to insert 3 movies into the database for now. These are my favorite movies. That's why they're there. And then finally, we're going to go in our application properties and we're going to do something here. So I'm going to rename this to be a YAML file. And then we're going to set an application YAML. All right. So we give our application a name. We also say that we're not running on a platform. We're just going to connect to the local config server. And then this gets overwritten in our test container case. So or it doesn't get overwritten, but gets used in addition. And then this is just to make sure that our unit tests don't fail, essentially. And then in the Kubernetes case, we're going to connect to the Kubernetes config server, which we'll talk about when we get to that in a little bit. All right. So I think we have everything we need here. So we can go ahead and run the application, or run the test container application. And it should spin up all the containers we need. And then also start the application. We're waiting for the database to get all set up. And then we should be able to test everything out. So app is started. We can go to our browser window here so we can test it out. I'll make that bigger. There we go. All right, so we can go to localhost 880. And it says, "Hi, George, would you like to go see Indiana Jones?" And you can see a random name, random movie. So our app looks like it's working. Obviously, we can go in here and in the movie controller, we can say, would you like to go see the movie? This, and then we can rebuild our app. And it should, the magic of Spring DevTools, restart the application. We get to see, and I forgot the space, so that'd be useful too. But you see it got updated here as well. So cool. So we have our app running locally, which is awesome. It's in the middle of restarting again because I changed it. There we go. Now we got the space. Cool. So now we want to get this app working in Kubernetes, right? How do we go about doing that? Let's jump back to our slides. What about Kubernetes? It's more than just getting a jar running, right? So the first thing we need is a cluster, right? We need a Kubernetes cluster to deploy this thing to. So we need some place to get that. We need to package our app in a container of some kind. So we need to figure out how that gets done. Then we need to place the container and all the containers for all our dependent services that we need in a registry. And that registry needs to be able to be found by the Kubernetes cluster. And so we need to figure out how to make all that work. And then we need to actually deploy everything. So we need to deploy the MySQL server, the config server, the name server, and then deploy our application. In doing that on Kubernetes involves writing a whole bunch of YAML to get that done. And on the surface, it seems like very easy to go about doing this. It's actually quite complicated and it takes a lot of orchestration, and you need to know a lot of things, best practices, and address different security concerns. So let's break this down a little bit. So first, let's start off by where do we get a cluster? Right? So we have a lot of options here as to where we can get clusters from. We can go to the cloud and get a cluster in AWS or Google Cloud or Azure, or use VMware Tanzu, or we can choose some local development options like K8S or Docker, or Kind, or Minikube. All are valuable in equally good choices. But in my opinion, I like the kind of sticking to the lightweight containers for local developer stuff. And so there's a great open source command line tool called CTLPTL. Don't ask me what it stands for, but it's pretty cool. It allows us to basically spin up a cluster using any of these lightweight Kubernetes instances, and also connect a registry to it. So we have a place to place our containers. So let's go ahead and see how that works. So we can say CTLPTL, create cluster, and we'll use Kind as our Kubernetes cluster of choice. And then we're going to actually create a registry as well. And so we're going to execute that, and it's going to go ahead and do its thing. And then we'll come back to that after it's done here. That solves the cluster problem. Now about the container problem. We need to package our app in a container. So we can just use a DockerFile, right? That's easy. Here's a DockerFile that's only 3 lines long that would actually accomplish exactly what we would need to do. So why is that a problem? Why is that so hard? That's not too hard, right? There's a lot of things that we don't think about when we think about using a Dockerfile. First, we need to write that same Dockerfile over and over again for every single application that we have. And that just like, why do I need to write that Dockerfile over and over again? Why can't the thing do that for me? So that's point number one. And secondly, there's a lot of best practices that actually we should be considering when creating Dockerfiles. And if we don't adhere to those best practices, we end up with less efficient containers, which end up actually costing us dollars because they're maybe using more memory or CPU than they should otherwise. And potentially we could expose ourselves to various security concerns because the container itself isn't running in a secure fashion. And knowing all the best practices and being familiar with all the security concerns is something, again, as a developer, has nothing to do with me building applications. It's all this kind of extra fluff stuff that I don't really want to know about. And then you have the problem with the Docker containers are like based off of base images. And what if there's security vulnerabilities in those base images, and you need to know about them and then understand that you have to update the container and knowing when to do that, et cetera, et cetera. That's always a constant concern and just a cost to us. And frankly, as a developer, I really just don't care about all this. I want it to do it for me. And luckily, we have a solution to that. And that's by using things like build packs and Paketo. So build packs know how to transform your application code into runnable artifacts. Basically can take the code that you have and we're going to get something useful out of it. And Paketo uses a builder to determine which build packs to use in order to make those artifacts. So Paketo says, okay, I'm going to look at this application code. Oh, it's a Spring Boot application. I need these 6 build packs generally to build an executable jar file that's going to run in a container. And Paketo and build packs then take care of implementing all the best practices as far as creating that container. So we don't have to basically worry about it. We don't actually have to recreate a Dockerfile either. We just run Paketo and it takes care of doing this all for us. It also makes updating our applications very easy. So if there's a security vulnerability in one of the different layers that Paketo creates, then no problem. We're just going to replace that layer and reuse the other existing layers. And it'll actually speed things up quite a bit. allows us to patch our containers fairly quickly without having to recreate everything. And the awesome part about this is that with the Spring Boot Maven and Gradle plugins, they're all built in, and we don't actually need to install any other additional tools besides just make sure we have Docker running on our machine. That takes care of the container part. Now, what about all this YAML stuff? This is probably the least amount of YAML you could get away with writing in terms of deploying a basic Spring Boot application to Kubernetes. And again, a lot of this is boilerplate stuff. A lot of it looks exactly the same between all Spring Boot applications. And just like with Docker files, there are a lot of best practices that you need to make sure you implement in order to make sure that your containers are run efficiently and you're not exposing yourself to any security vulnerabilities. So again, just like with Docker files, it would be great if we had a tool that would take care of generating all this YAML for us so that we don't need to write it over and over again every time and make sure that we're doing it in the correct way. Because again, it has nothing to do with me building good applications, and it has everything to do with me trying to get this thing running on the platform. And so luckily there's a project from Eclipse called JQ. It has a whole bunch of features related to running Java applications on Kubernetes. But one of those features that is of interest in this case includes the ability to generate Kubernetes resources, or what's better known as the YAML files, based on some opinionated defaults. So JQ looks at your Maven or Gradle file and says, okay, based on what I see here, I can create this YAML file and get this application running on Kubernetes. And just like with Spring Boot, when we have opinions, we want to provide ways to override those opinions. So that is also possible if you find that you need to customize things a little bit for your specific needs. And it's an awesome tool that just takes care of the YAML problem for us. The other issue that we have here is around connecting to the services. So we have a MySQL database that's going to be somehow running on our Kubernetes cluster. And we had to figure out the username, the password, the host name, the port, and also the database name, and configure our application to point to that database. So we need all the proper configuration for Spring Data in order to get that stuff working. So there's a specification called servicebindings.io that is useful around exposing the necessary information for connecting to different services using secrets. And secrets are just sensitive configuration data that you can store in Kubernetes. And the Spring ecosystem has a project called Spring Cloud Bindings, which implements that specification for Spring apps. And the Spring Boot build pack automatically adds Spring Cloud Bindings as a dependency when you build your application, which is super cool. Now, we're going to use Bitnami's MySQL's Helm chart to deploy MySQL to our Kubernetes cluster. And it supports creating the service binding secret that we need. And so all we need to do then is connect the two. So once the secret is created, we just need to tell our container and Spring Cloud Bindings where that secret is located. What we're going to do is mount the secret in a volume on the container, right? So we have this secret here as a volume called MySQL, and this is the name of the secret that the MySQL Helm chart is going to create. And then we mount that at var service bind MySQL. And then we tell the build pack that all of our service bindings are located in var service bind. You already do that via configuring the Spring Boot Maven plugin and setting this environment variable here. And that will connect the two. Now, finally, there's a lot to automate here. We have to deploy several applications, the MySQL, Spring Cloud Discovery Server, Spring Cloud Config Server. We need to build an image for our application. We need to push all that stuff to a registry to run the Maven Gradle goal to generate the K8S YAML. We need to apply that YAML to run the container in the app. And it would be awesome if we could set up some port forwarding to test everything out and also remotely debug our application. And so it would be great if we could automate all this instead of having to script it all out ourselves. And luckily, that's where a tool called Tilt comes in. So Tilt will take care of automating all this. And you see an example of this Tilt file here on the screenshot. And we're going to actually take a closer look at that in a little bit. But we're also going to use Tilt to assist us and make our developer experience a little bit better. And the way it makes our developer experience a little bit better is it also, in addition to using some port forwarding tools, it also enables us to do some live reload, just like we would in using Spring Dev tools. So whenever we make changes to our application, we can see those changes reflected in the application running on Kubernetes near instantaneously. And the way we do that is take advantage of the build packs live reload feature by enabling that again in our Spring Boot Maven plugin. And then also using this custom build, we have a live update here feature in Tilt, which is going to sync our class files over to the actual container. And then once those class files get there, the live reload feature kicks in and restarts the application just like it would if you're doing it locally. So that's super cool. And we'll see that in an example as well. So let's go ahead and get started doing that. Now, the first thing we're going to do here is we're going to go to our POM file and we need to add JCube and we need to configure the Spring Boot Maven plugin with the configuration options we just talked about. So we're going to go down to the bottom here and we're going to actually add a separate profile to do this in. And so here, if we look in this profile, well, there's actually two profiles. The first profile gets kicked on when we're building on an M1 Mac because we need to use a different build pack to make sure it builds a container that's compatible with my Mac. So that's just for me specifically on M1 Macs. But the second profile is the real where the magic happens here. So we have our JCube plugin that gets added here. And then we have a Spring Boot Maven plugin where we're going to configure things where you basically say we want to use Java 21. We're going to enable live reload and all our service bindings are going to go in this directory. Now, the other thing we're going to do here, because we're going to not use Eureka when we're on Kubernetes, we're going to use the Spring Cloud Discovery, Kubernetes Discovery Server. We're going to add another dependency here. And we're going to add Spring Cloud Starter, Kubernetes Discovery Client to the class path. And we'll see how that gets configured in a little bit. And the next thing we're going to do is actually add our tilt file. So we're going to start creating our tilt file to automate all the stuff we need to get done here for Kubernetes. So we'll create a new file called tilt file. And here is our tilt file. So I've added a number of what's called custom tilt extensions that make a lot of the stuff we talked about a little bit easier. They're all in this GitHub repo right here if you want to take a look at them, but they assist in doing some of the things that are Spring specific that we talked about here. So the first thing here is we're going to deploy MySQL. And actually, this isn't necessarily Spring specific per se, but I simplified the steps needed to do this. Under the tilt also allows us to deploy Kubernetes resources with Helm charts. So again, we're using the Bitnami Helm chart and it wraps all the code that to use the Bitnami Helm chart. And this string that we're passing here is just the name of the database that we're asking the Helm chart to create. So that we're configuring the Helm chart to basically create this database and also create that service binding secret that we talked about. And that's all done in this extension that I've created here. Now we're also going to create a config map. And this is a config map that's going to contain configuration specific for our frustration-free K8S app on Kubernetes. And it's going to create this config map. I'll explain what we're doing here in a second. So we're going to create a new directory called K8S. And in that directory, we're going to create a new file and put this YAML file in here. And so this is where we actually, since this is specific to Kubernetes, we're enabling the Spring Cloud Kubernetes Discovery Client and the Discovery Server URL. We're specifying where that Discovery Server is going to be located, and it's going to be located at this host name once we deploy it to Kubernetes. And so we also disable Eureka because we're using the Discovery Client. And so that config file is going to be used and served up by our config server when we make a request to get configuration for frustration-free K8S. Okay, so we'll see the config server get deployed in a second. Then we're going to do our custom build. So this is our build to build a container for our application. So you can see we're executing Spring Boot build image. We're passing the image name with the name that Tilt knows about. That's what this variable is here. We're enabling the dev profile because we need to use JCube plugin. And we have specific configuration related to the build image plugin. And we're telling it to skip tests. And then we're saying we want to watch files here for any changes. And then when they change, we're going to sync those changes in these directories in the running containers. That helps out with the live reload stuff. Then we're going to deploy our config server. And so this is, again, another extension I wrote that does that. Again, this extension contains all the YAML that's needed to deploy that config server. So again, you don't need to know about that. And then this is a configuration file config that will be created from this configuration file for the config server specifically. So again, we're going to go up in our K8S directory here and create this file. And all this file is really doing is also saying that in addition to using config maps for the configuration data for the config server, we're also going to use this Git repo. And this Git repo actually looks pretty similar to what we had in our test YAML from when we were using test containers, right? We're just using SpringSQL init and exposing some actuator endpoints as well. All right, back to the tilt file. And then next we deploy our discovery server. Again, this is a custom extension, which contains all the YAML to deploy the discovery server to our Kubernetes instance. And then finally, we're going to actually deploy our application YAML. So here we generate the YAML within this bash script. So I'll show you what that looks like and why we do that. It'll make a little bit more sense once I show it to you. And all this is really doing is running the JCube K8S resource goal with the DockerFile enabled. And that's creating a YAML file that lives here in target classes meta in JCube Kubernetes YAML. And then we cat that so that we get the output of the YAML. And the reason why we need the output of the YAML is obviously we're going to apply it to our cluster. We want Tilt to do that for us, but we're also going to modify it a little bit. So we need to modify the JCube Kubernetes YAML for remote debug. So this is again a custom extension which sets the build pack runtime environment variables to enable remote debug and also exposes the remote debug port in our container. And then we also add the volume mounts that we saw in the slides for the service bindings here into the YAML as well. So that gets us the YAML that we want to deploy. And then we tell Tilt to deploy that YAML. And then we also tell Tilt to deploy the YAML for our name service. So the name service team has created a customize configuration. This is just a way of generating YAML via a tool called customize. So we can run kubectl customize and point it at that directory. It will give us back a set of YAML that we can then also apply to our cluster to deploy the name service, which is great. Thank you to the name service team. And then we create a resource in Tilt for that name service. Then we can also create a resource for our application exposing port forward 8080 and 5005 for remote debug. So before we actually run this Tilt file, we actually need to do one additional thing. And so we need to make sure that this batch script that we created is actually executable. So we're going to say that and make the bash script executable. And then we're also going to, then we should just be able to say Tilt. And Tilt has a nice little web UI that we can view to see how things are going. So it's going to process that Tilt file, and then it's going to start deploying everything that the Tilt file describes as Kubernetes resources. So we get some more details here. We can see all the logs from all the different containers or resources that we've defined. So it's going to spin up the MySQL service server. It's going to spin up the Kubernetes discovery server, the config server, and it's going to spin up the name service. And then our application is depending on these things, these 4 different services. So it's got to wait until they're actually done. So right now it's just waiting on MySQL to finish, which is always the slowest one. But usually in about a minute, everything gets spun up, and then we can actually start deploying our application. All right, so we finally got the MySQL service up, and now we got our application building. It's first running the script to build the container. So it's running the Spring Boot build image plugin. And you can see Takedo and doing its thing here. It's detected all the different build packs that it's going to use. It's then going to add different layers for all the applications. It's going to push the container to our registry. And then it's going to actually deploy the container using the YAML that we defined in the JCube plugin. So there's our application actually starting up. And with it up and running, we should actually be able to test it out. So it's completed. I think it's pretty much ready to go. The cool thing is we got our port forward set up here. So we can click on 8080 and we can say, hey, John, would you like to go see the movie Indiana Jones? Again, we refresh this, we get Paul in Ghostbusters, John in Ghostbusters, John in Star Wars, George in Indiana Jones. You get the idea. So cool. It's working. We were able to get that thing up and running. We didn't write a single Docker file. We didn't write a single YAML file. And yeah, we just wrote this tilt file and it spun everything up for us. So let's see if all of the functionality we expect is working. So go back to our movie controller, for example, and we're going to, in here, we're going to get rid of this again. And we'll go ahead and rebuild the project. And so it should detect that the class files changed. And it did. So it's actually already restarting, but you can see up here, I copied some files to the container, some new class files to the container, then restarted the application. And so we can go ahead and see that the text got removed. And we can also remote debug stuff here. I don't know why this is complaining per se. It's weird. Wonder why. Anyways, it's working. So I'm not sure. Maybe the IDE is a little confused, but anyways, we can set our breakpoint here. We can go into run and edit configurations. And we're going to add a new remote debug here. And here we'll click OK. And then we can debug this. So we can connect it. So if we go ahead and hit endpoint, we see get our breakpoint gets hit. Again, this running on Kubernetes. We can step through the code. We can see all the things that we want to see and test out anything that we need to see or debug anything we need to debug, which is super cool. The other thing I just wanted to show quickly is if we go to, I want to show the service binding stuff in action here. So if we go to actuator env, we can actually see these Kubernetes service binding specific. These are property sources that Spring Cloud Bindings actually adds for us. You can see it's detected the service binding from the secret, the Kubernetes secret that got created in our application. In when we deployed our MySQL Helm chart, and it's added a property source for that with all the information for connecting to it. And again, this is all done automatically for us with the magic of build packs in Spring Cloud Bindings, which is super cool. So that's it. I hope you can see how simple that things can actually be. I appreciate you watching this video. And if you have any questions, please reach out to me again at Ryan J. Baxter on X, or what's formerly known as Twitter, or you can easily find many different ways to get in contact with me, but happy to chat, have any questions, and please have a great night and great day. And I'll talk to everyone soon.